Alright, this is Math 2, Unit 13, Lesson 3, Form G. I'm going to do some homework help with numbers 1, 2, 3, 4, 5, 6, and 7, looking at permutations, combinations, and the fundamental counting principle. Okay, the first question says the band sells t-shirts 3 sizes in 2 different colors. How many different t-shirts are there to choose from? So for this first one, we're going to be taking our options 3 and 2 using the fundamental counting principle and multiplying them together to have 3 times 2, which gives me an answer choice of 6. For number 2, same idea here. We have a baseball team. We have 3 different options. We have the finish, the length, the wood type. I have 2 different finishes. I have 3 lengths, and I have 2 woods. And so again, using the fundamental counting principle, I multiply together and wind up with 12 different choices for number 2. For number 3, I'm looking at how many different orders can 5 runners finish a race in. Essentially, you have a first place, a second place, a third place, a fourth place, and a 5th place. And those would all be interchangeable. So if I multiply that out, I end up with how many different combinations or orders that could come in, and that would be 120. For number 7, it says evaluate 7 with an exclamation mark. Exclamation mark means 7 times 6 times 5 times 4 times 3 times 2 times 1. And so again, if I get out the calculator there, we have 7 times 6 times 5 times 4 times 3 times 2 times 1, and I end up with 5,040 for number 4. Number 25, I could work the whole thing out if I wanted to, but what it's asking me is I'm doing 25 times 4 times 23 forever, all over 24 times 23 down forever. If you set it up this way, you notice everything's going to cancel out vertically except for the first 25. So the answer here would actually be 25. On number 6, it wants to know how many possible combinations of 3 items from a group of 5 are possible. To do this, we need to use the combination formula here, which is the number of items in the whole group combination, the number of items we're going to look for in the smaller group, and that's equal to the big items and then the little items n minus r. Okay, so in this case here, my n is 5, my r is 3, and so when I rewrite this, I'll have 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1, and then I have 5 minus 3. That's how I set that one up there. If you notice, I can eliminate 3's, the 2's, the 1's, right, by reducing, and that leaves me with 20 over 5 minus 3 is 2 so far. 20 divided by 2 is 10. So there are 10 different combinations that I can make with 3 items from 5 groups. For number 7, it's a different formula to find the permutation. This is what happens when orders matter. And that's what this is about. So permutation is order matters. Like it matters what order these things go into. The formula for that is the number of items, the permutation, the order we're looking at there, equal to the number over that, and then we do n minus r exclamation point. Okay, so in this case here, our number is 6. We have 6, 5, 4, 3, 2, 1 on the top, and then n minus r. So this would be 6 minus 3 is 3, so that's a 3, 2, and a 1. Again, the 3's, 2's, and 1's are eliminated, and 6 times 5 is 30, times 4 is 120 for that one there. Okay, so the key things here were a couple different formulas on permutation formula and a combination formula and the fundamental counting principle. Those are the 3 main concepts in this lesson, and hopefully that makes sense there. The other problems, just kind of look through and figure them out, and ask your teacher for extra help if you need it. Thanks.